Welcome back. In this module, we are going to discuss about software engineering. The objectives of this module are to understand the importance of software engineering, to get an idea about the issues related to the development of a software, to study about the significance of software engineering apart from traditional engineering, to understand the different phases of software development, to learn the software lifecycle. Software engineering is the branch of computer science that deals with the principles to guide the software development process, which leads to efficient, reliable software products. The problems faced in developing software systems are similar to writing smaller programs, but will vary in size and quantity. The development of large systems often requires efforts of more than one person over some period. The personnel assigned may change during the development period. Hence, the software engineering should include the personnel management and project management apart from computer science. But in this module, topics related to computer science are discussed. The software engineering discipline. The problems involved in software engineering are estimating the cost in time, money and other resources to complete the project, dividing the project into manageable modules, ensuring the compatibility of modules, communication among various parts of the systems, measuring the progress, etc. Since engineering is a well-established field, there are some previously developed techniques to face with some of the above mentioned problems, but there may be fundamental differences between the properties of software and those of other fields of engineering. These may lead to cost overrun, late delivery of products and dissatisfaction of customers. Such distinction deals with constructing systems from prefabricated generic components. In the traditional engineering discipline, the off-the-shelf components can be used to construct a more complex device. But in software engineering, previously designed components may be domain specific and internal design is based on a specific application. Hence, the use of generic components is limited. So, the complex software systems should be started from scratch. Another difference between the software engineering and other engineering disciplines is the lack of metrics or quantitative techniques for measuring the properties of the software. There are some methods of measuring the complexity and quality of a product in traditional engineering discipline, but in the case of software products, these methods cannot be applicable. Thus, research in software engineering is currently progressing on two dimensions. Some researchers called practitioners work towards developing techniques for immediate application. The other type of researchers called theoreticians search for principles and theories on which more stable techniques can be constructed. In the present scenario, we are mostly dependent upon large software systems. Every field of life like economy, health, government, transportation, defense, etc. is using software systems for their processing. This implies that software errors can cause disasters and the progress of practitioners and theoreticians is enormous. The application of computer technology to the software development process results in computer aided software engineering or CASE. CASE tools include project planning systems, project management systems, documentation tools, prototyping and simulation systems, interface design systems and programming systems. Once a project is found to be feasible, project planning is to be done by the project managers. This planning is to be completed before the beginning of any development activity. The project planning systems support the major activities of project planning such as cost estimation, project scheduling and personnel allocation. The goal of software project management is to enable a group of software developers to work efficiently towards successful completion of the project. Project management systems assist in monitoring the progress of the development project, and documentation tools assist in writing and organizing documentation. A prototype is a rough implementation of the system. These are built using shortcuts and a very crude version of the actual systems. The prototype is used to illustrate the input data formats, reports, messages and interactive dialogues to gain the understanding of user needs. These prototypes can be developed using the prototyping and simulation systems. The interface design systems assist in the GUI development. Writing and debugging programs are supported by programming systems. Some more sophisticated case tools include code generators that produce high-level language programs if the specification for a part of the system are given. Besides the research for methods of developing better quality software systems, professional organizations have contributed their efforts by setting standards of ethics and professional conduct among their membership. The Association of Computing Machinery or ACM and the Institute of Electrical and Electronics Engineering or IEEE are at the front to adopt codes of professional conduct and ethics. The software life cycle. The software life cycle has a well-defined iterative process. The process theoretically never ends as the cycle gets repeated. The software life cycle is the most fundamental concept in software engineering. The following figure presents a view of the software life cycle. Once the software is developed, it enters a cycle of being used and modified, which continues for the lifetime of the software. This is true for any of the manufacturing product, but in other disciplines, a modification is better known as a repair because their parts deteriorate. Software does not deteriorate, but there may be some errors found or there may be some changes in the application where the software is used. Whatever may be the reason for modification, the program and its documentation should be well understood by the person. Otherwise, modification may introduce more problems than it solves. So, generally, the software part which needs modification is discarded and develops a new system instead of modifying the existing package. But from experiences, it is clear that some effort during the development makes the modifications easier when required. Therefore, most of the research in software engineering focuses on the development stage of the software life cycle. The various phases of software development are analysis, design, implementation and testing as shown below. Analysis. The development phase begins with analysis. It is the specification of the services expected from the proposed system. The conditions such as time constraints, security, etc. should also be identified. Analysis phase needs the input from the future user of the proposed system. In a traditional software development context where the user is an entity, the analysis starts with a feasibility study conducted by the user. If the software is produced for the mass market to be sold or downloaded through the internet, the user is less precisely defined entity and analysis begin with a market study. As the needs of the users are identified, they have to specify a set of requirements that the new system must satisfy. These requirements are stated in terms of the application. For example, data must be restricted to authorized users. After the system requirements are identified, they are converted into more technical specifications. Hence, the above requirement may be stated as the system will not respond until an approved 8-digit password has been typed at the keyboard. The analysis phase of the software development concludes with a document called Software Requirement Specification or SRS that identifies the requirements and specifications of the proposed system. the professional organizations such as IEEE and large software clients have adopted standards for its composition. That is, the software requirement specification is a written agreement between the parties concerned and is a method of solving the disputes that might arise later in the development process. The software requirement specification should define a firm objective. It is assumed that pure communication and changing requirements are the major causes of cost overruns and late delivery. These can be resolved if the requirements are specified and both the parties agreed upon it. Design. The analysis concentrated on what the proposed system should do, whereas the design concentrates on how the system will fulfill the requirements. At this phase, detailed plans according to the requirement specifications are developed. The result will be diagrams and models of the proposed system with different levels of details. The design process can be mainly categorized as high level or conceptual design and detailed design. The conceptual design provides only a conceptual or logical view of the overall system. The details are not specified. During the detailed design process, the inner details of how the system can be implemented will be specified. The design of the software includes the design of user interfaces such as input and output. The other major considerations are database, procedure, control and documentation. Implementation. Implementation involves the actual coding of programs, creation of data files and development of databases. Implementation is considered to be a bottom-up process in which individual modules are programmed and then combined to form larger components. Commonly used approach is to construct the partial modules and use in larger components and then expand to complete fully functional components. Another structural way to implement the software is a top-down approach in which a skeletal version of the entire system is implemented first and then later provides a complete system. A programmer rather than a software analyst contributes to the implementation process. A programmer is assigned with writing programs to implement the design produced at the earlier stage. Even though we made a distinction between the analyst and a programmer, today the steps in software development process are intermixed. Testing. Testing is of two types. One is validation testing to confirm that the software system implemented is according to the requirements and specifications identified during analysis phase. The other is defect testing to identify and correct errors in the program. But even after the satisfactory completion of the testing phase, it is not possible to assure that a program is error-free. Since the input data domain of most of the programs is very large, it is not possible to test the program for each value in the input domain. Thus, testing involves a set of test inputs or test cases and observe the behavior of the program whether it is as expected. The commonly used terms associated with testing are error. It is a mistake committed during the development phase. The error is also termed as fault, bug or defect. Failure is a manifestation of an error. Test case is a triplet consisting of data input, state of the system and expected output of the system. Test suite. It is a set of all test cases with which a software product is tested. The testing process is depicted in the following figure. There are two main approaches to systematic design of test cases. They are black box testing and white box testing. In the black box testing approach, the test cases are designed using the functional specifications of the software without any knowledge about the internal structure of the software. So, the black box testing is also known as functional testing. The white box test cases require a deep knowledge about the internal structure of the program and are also called structural testing. Both validation testing and defect testing are closely associated with implementation. Each module in a well-designed system can be tested independently of the others by using simplified version of the other modules to simulate the interactions between the testing module and other parts of the system. As the individual modules are completed, these are combined to the larger system and leads to overall system testing. Experience has shown that even after significant testing, the large software systems contain numerous errors. Some of these may not be detected during the lifetime of the system, but some others may cause severe damages. The software engineering is to eliminate these errors and hence need lots of research. Now let us summarize what we have discussed in this module. This module provides an introduction to the broad field of software engineering. This module starts with a comparison of software engineering with traditional engineering discipline. An overview of the software engineering tools and various phases of software engineering are given here. Since the development phase is of major consideration, the development life cycle of a software product is discussed in some detail. This module concludes by pointing to the importance of research in the software engineering field. Before we attend the next unit, please try to answer the following questions. What are the major distinctions between software engineering and other engineering disciplines? Suggest any good metric for measuring the complexity of a program. What are the different phases of a software development life cycle? What are the different types of testing associated with a software system implementation? What is meant by case tools? Compare between procedure and function. Write a note on software requirement specification. Books for your reference. J. Glenn Bookshare, Computer Science An Overview, 10th edition, Addison Wesley. Rajiv Mal, Fundamentals of Software Engineering, 3rd edition, PHI Learning Private Limited. Hope you enjoyed this session. See you next time. Until then, bye.